Hello, I wanted to show you a little demonstration of ThreeJS, and this is an example of a star field based off of the example that Red Stapler made online on YouTube. And he made a nice video that showed dots coming at you in the same type of fashion. Now I wanted to learn some things about ThreeJS, so I'm like, well, somebody in the comments had said they wish that Red Stapler had made the line version instead. I'm like, oh, well, that'll be a good way for me to come in and kind of try to learn how this works. So this is what I've made and learned a whole bunch about ThreeJS at the same time. So I want to go over this and share this with you if this is an effect you're looking for. I am working in the Visual Studio type world here. And I'm going to move this over a little bit more so this can be more centered here. And you'll see that this is actually a very simple example. Very simple. And it's not hard at all. I had to do it a little differently than what Red Stapler did, just because I'm working with lines instead of points. But I'll try to explain that to you the best I can here, and as quick as I can. One kind of nice thing about ThreeJS is that if you close down that browser or you go to a different document, believe it or not, the graphics stop on the other screen. So if I close this down here, you'll see that I can come down and hover, and it's not actually working anymore. So it's kind of a nice thing about how they have it set up. And then once I make it active again, the screen active, then it starts up again. But let's just go through this code real quick. The way the axis is set up here, I changed it from the way that Red Stapler had it as well. I have the Z-axis coming right out of the monitor towards me. Oh, and by the way, if this, I don't know how the screen capture is capturing the star field right now. When I was playing it back the first time I tried to make the tutorial, it was choppy here and there, especially when I bumped up the number of points. Because I can go in here and just crank this up. I hit Control S to save, and then I go reload, and this might get a little choppier on you. So the screen capturing, the Camtasia program might not be working so well with this, but on my screen where I'm seeing it right now, it's perfect. There's no drop frames. It is exact. And so I bumped it up to 100,000, no problem as well. Anyway, I'm going to take this back down to a little more reasonable level. And then just refresh here. Okay, so that's a little more doable. So anyway, I have the Z-axis coming out at me. And then the X and Y, or X is going left and right, and Y is going up and down. And the way I have this is I create, right now it's 1,000 lines are being on the screen at the same time. And I start them out is 2 points, a leading point and a trailing point. They start out at the exact same position, and then they both start accelerating towards, right towards along the Z-axis towards my face off the screen. And the leading point has a greater acceleration than the trailing. And that's what gives you the different looks. That's what gives you the lines. And so that's basically it. So if you want to jump in here now, I am using this module mode. And this confused me at the beginning. It seems like there's two different ways to run this, from modules or directly from the three.js. So you'll see a lot of examples online that's using the three.js, so get rid of the module. But you'll see here the script type is module. So I don't honestly understand how it all works. It's just I took it from the examples, chopped out all their code, and just started over with what I wanted to create. And here I'm defining a whole bunch of variables. Don't let the var and the let get you. This is just how I did it. It worked both ways, whether you use var or let. So I just make this variable line count. So I'm going to do 1,000 lines, and what I have to do is I have to set up buffer geometry. Now I really like this buffer geometry because you can set all these different attributes. So in one object you can have a whole bunch of different things that are accessible to you, and it makes it really nice. The buffer geometry supposedly is easier to send that to the graphics card, the graphics processing unit, the GPU, versus normal arrays and different types of objects that have data in them. So what you can do now that I've made the buffer geometry is I can just come down and I can set attributes. And I'm going to set an attribute called position. This can be called anything I wanted. And I'm actually going to store both point positions in here. So what you'll see here is you'll see the 6. That represents the XYZ and XYZ. I need 6 floats of data to handle one line. So it's again, the leading point and the trailing point are all captured in here. Now what this 3 is, this seemed kind of confusing to me at first, but this 3 is basically telling the software or wherever you're going to use this, it's telling it that this is set up as 3 points of data followed by 3 points of data. Now if I only had this as, for example, 3, that would be the same thing, but now I only have 1 point. Okay? If I had this as 9, that means I had 3 points stored in here, but each point was 3, X, Y, and Z. Okay, if I had this, let's say, for example, 10, well, let's just do something more reasonable. Let's say 4, and I had this as 2, that means I'd have 2 points of just X, Y. That's how at least I think that's how that all works. Maybe you never deal with X, Y in here, but I wanted 6 data points, and they were 3 each, because I will use this buffer geometry to send to a specific line segments routine where I send in that entire geometry, geom buffer geometry. And so this function here wanted it set up like this. At least that's my understanding of it. It works. I set another attribute for this, and I wanted to keep track of the velocities. I have to keep track of the leading point velocity and the trailing point velocity. They changed the entire route from their initial creation all the way to when they go off the screen. So I have to set all those as well. Now here I just needed individual values, but I needed 2 of them. So that's all that is. And so once you've made that data object, you then can access it through here in a little bit more your normal way. So I'm going to get the attribute position from this buffer geometry, and I'm going to set it as this POS thing, and then I'm going to make the array. So this is going to act like an array like you're used to dealing with. And the same with the velocity. I get the velocity attribute from the data, and then you do it this way, and you have access to it. So in my program, I'm just using PA, VA, and geom. And you could probably combine these 2 lines into one and these 2 lines into one, but I don't know, maybe not. So those are all defined globally, and so I then get into function init right here, initialize, which is called way down here, and then all it's functions from then on. So in the initialization function, you obviously are going to make your scene, you're going to make your perspective camera, and these values, you've probably seen other examples of what all these means. You can just look it up. And all you do to look these things up is just Google 3.js cameras, and you'll find the different types of cameras. Or you do like I did here. I Googled 3.js buffer geometry. And so here it tells you about how the buffer geometry works. Yeah, let's close that. And I think when I showed you the 4 and 2 that I think it always wants X, Y, Z. But this is an example. You got, hopefully that kind of proved you what's going on there. So I'm only making 2-point lines. That's why this needs to be a 6. If I was making 3-point lines, I would want this as a 9. I believe that's how that works. So cameras. Okay, so I set up that camera position. So I have the camera coming out of the screen, pointing back towards the origin. And I didn't rotate it at all. So the render, you just set up a render. I did put anti-alias to true. Don't really need that, but it just seemed like a nice thing. Set size for the render. This is all just simple stuff that you see in every other example. So what I needed to do is come down here and actually start where are these points going to start. And so the X is going left and right, Y is going up and down, and Z is coming in and out of the screen. And so I had to make enough points here to make this look kind of neat. So this 400 you can see is obviously double the size of this because the screen's a lot wider than it is taller. So for my X values, I wanted all my points to start out between -200 and +200. So that's what this does, because this random gives you 0 between 0 and 1. You multiply that by 400, it gives you 0 to 400. Well, if you subtract half of 400, you then get a value between minus 200 and plus 200. So it's my x points, x values there. The y values are going to be between minus 100 and plus 100. The z values are going to be right here. It's going to be, what would it be, between minus 100 and 400. So again, you can play with these to see, and I'll show you a little kind of neat things you can do with that at the end here. But then, so that this defines the first point, and then I just make the second point equal that. That's simple, very, very straightforward. So you got 2 points now. They're going to be right on top of one another. And then I now have to put those values into my buffer geometry. So the way you do that, remember I said we're going to access the position array with PA. And so now you can see how this works. So this technically is a two-dimensional array, but it doesn't function like that. You don't have, an index here and then another index here. Okay, you don't do it that way, right? So all you're going to do here is just think of this as actually a linear array that just kind of reminds you of a two-dimensional array. And you can't add points to this or subtract them or anything else. Once this is made, it's made. So regular arrays you can push and do stuff like that. You can't do that with these, and you can't get rid of points in these buffer geometries once they're made. So anyway, what I'm going to do is I'm going to access the first XYZ, and that's just, see this 6 here is obviously matching this 6 here, right? So I'm doing the line index, would start out at 0, so this would literally be index 0, index 1, 2, 3, 4, 5, and then for the next set of points, it would be 6, 7, 8, 9, 10, 11, and then 12, 13, 14, 15, 16, 17, okay? So it is a linear array, but it kind of seems like a two-dimensional array. And so that's how you access these things. So the first 3 of each group is my XYZ, and the second 3 of each group or index. You just can't talk the same way as you normally think of as arrays, because you just gets mixed up. So here's the first point, here's the second, that's the point. Then you got to set up the velocities. Now I want both points. You can see how you access them here. So here again, it's the velocity array, which is got from the attribute called velocity up here, and these were just 2 separate float values. They were only 1 each, one float each, and that's all there is to that. And so you access them this way. Now, if I had a 2 here, I don't think it would really matter, because I'm not sending this data to some function that's expecting data in a certain way. But, because I can access each one of these individually, so it's probably not critical if this is a 1 or a 2. But this is the way I think buffer geometry, this is just kind of the way it would normally be used, so I'm just using it that way. So line index, so here's the leading point, and here's the trailing point for each one. And I set them to 0 because I want the velocities to start out at 0. That way, in the distance, it starts out as just a dot, a single star is what we're trying to emulate here. So that's all you do. You just fill up this line count, 1,000 lines, and actually the position, this position part up here will actually be, what will it be? It'll actually be 6 times 1,000. 6 times 1,000 will actually be 6,000 actual float values. But that's irrelevant. It can handle that no problem. As you saw, I can bump this up to 80,000 and handles it no problem. And so that's it. So now what I'm going to do is I'm going to actually create the lines, and one command does that. So this line segments, if you actually look this up, is expecting some type of geometry to be sent into it, but I'm sending everything into it. So I don't have to for loop, I don't have to have a for loop through each line, which is kind of nice. So I do make a basic material here for a line, and it's just white. I could change this to red, FF0000, and that looks kind of neat too. But then I just make this new variable in line segments. So this is a specific function. Again, you can look it up, just Google it. And I send in the geometry, which is this guy right here. And the material, which I just made, which is this basic material. Then I just add all the lines to the scene at once. So if it's 1,000 lines at all at one time, or 80,000 lines all at one time, it's just added. Then you can do this simple window event listener resize thing, and you've seen this on a lot of examples, I'm sure, and then the function to resize. All that does is so that when you're running this here and you resize the screen, it all looks normal and it works. And if you take out that function call in and of itself, you'll just see what it does. You can just comment that out, and you'll see that it does look goofy then when you resize it. It's probably not what you want. So I just added that in there. So then the real nuts and bolts of this is really in the animate function, okay? And what I have to do then for every frame, and this I believe by default runs at 60 frames a second, I have to go in there and just change the Z positions of each point and the velocities, so that next time it comes around, the velocity can keep getting added to, and these points come at us faster and faster. So again, I'm going to use a for loop, and I'm going to go through the line count again, so it knows exactly how many lines are there. And for each line, I now have to add, these are my acceleration values right here. This is for the leading point, this is for the trailing point, and this is the velocity for the leading point, this is the velocity for the trailing point. So all I'm doing is every frame, it's going through here and adding a little bit of acceleration to the velocity, so that the velocity I come down here and then add to the position. Now remember, these are coming at me, so as they're coming towards me, they're moving along the z-axis faster and faster and faster as they go by. So that's what this is. So again, I add a little bit of acceleration to the velocity of each point, then I add the velocity to the position, and that's it, okay? And so the positions of each point keep changing each frame. Now the only other thing I had to deal with is what happens when a line goes past the screen, past the field of view. Obviously you can keep sending them out there, but there's no reason to. So what I wanted it to happen is when the trailing point of a line got past the screen view, it automatically reset the entire line, both points, back to some random position on the z-axis, reset their accelerations, and put them through this whole thing again. So that's all this is here. So since I don't know the original z position anymore because it's been modified so much, I just figured out a new z position, wherever the heck you want on the screen, doesn't matter. It's not even the same as up here. I figured out a new z position and then put that back into the buffer, the new z position, and then I reset the velocities of both points, and then that's it. So that's the for loop. So that goes through and updates every dot, all 2,000 of them in this scenario, very quickly. And then what you have to do is you have to set this flag so that the renderer knows that these points have been modified. Even if you modify just one point in there, you'd have to probably tell it to update all of them. I don't know, maybe there's a way to just update a few of them, but anyway, we're changing all of them, so obviously we need them all. And then the renderer, you just that's set up there, and then you just request for frame animation. So what this does is it just keeps calling this over and over and over and over and over and over and over again, and doesn't stop. So that's all there is to it. I did leave these values here just in case you did want to modify the x and y's, but again, I'm just modifying the z. That's all I'm doing, and it's the fact that it's a perspective camera that makes it look like they're whizzing by. You would think that you'd have to modify all three axes to get them to go by like that, but the camera makes that look, gives you that look. And so that's really all there is to it. It's not real hard. You just had to do it quite a bit differently than Red Stapler did the dots, and he did that awesome. I mean, that's a great tutorial, and I was very thankful he did that, because that one tutorial got me interested enough into going and learning how to play around with this. And sometimes just getting started is the hardest part of a project. So I'm an absolute newbie to this. I just started playing around with this a few days ago. well, really kind of getting into it a few days ago. I procrastinated for a few weeks on it, just trying to get the environment set up because I'm not used to playing around with all this JavaScript stuff. So if you have questions, I'm probably not going to be able to answer them. So you're better off going to the forums and asking them there. Anyway, so the other source of confusion again is this module thing. But I hope you liked the video. I hope this helped you learn a few things, and it definitely helped me learn some more basic stuff about this, and very, very happy. So anyway, and then if you change this to red, it's quite fun. I don't know if I did that. If you change that to red, you actually take this to 80,000. Now again, I don't know how the screen capture is going to handle this. See, on my end here, it's looking absolutely beautiful. That's just such a neat look. It's a little overwhelming. So anyway, well, thanks for watching, and I hope you enjoyed this.